Alrighty, everyone, welcome to day 10 of Advent to Code. A few seconds here, and we will get into today's problem. Let's do it. You avoid the ropes plunging into the river and swim to shore. The elves yell something about meeting back with them upriver, but the river is too loud to tell exactly what they are saying. They finish crossing the bridge and disappear from view. Situations like this must be why elves prioritize getting the communication system on your handheld device working. Do you pull it out of the backpack? But the amount of water slowly draining from the big crack in its screen tells you it probably won't be much of immediate use. Unless it is, you can design a replacement for the device's video system. It seems to be some kind of cathode ray tube screen and simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at constant rate. Each tick is a cycle. Starting by figuring out the signal between the CPU. The CPU is a single register X, which is stood for value 1. It supports only 2 instructions. Add XV. Oh, building on a computer. Add XV takes 2 cycles to complete. After 2 cycles, the X register is increased by the value V. No op takes 1 cycle to complete, has no effect on other. CPU uses the instructions in a program puzzle input to tell someone the cell screen what to draw. Consider the following cell program. The no op instruction begins during the first cycle. At the start of the first cycle, the no op instruction begins execution. During the first cycle, X is 1. After the first cycle, the no op instruction finishes. Okay, at the start of the second cycle. During the second cycle, X is still 1. During the third cycle, X is still 1. After the third cycle, X finish executing, set to 4. Okay. Find the signal strength during the 20th, 60th, 100 cycles. What is some of these? Okay, so this is actually not too bad. So because it's asking for specific cycles, I'm gonna actually go ahead and do eyes. And we're just gonna go for the straight easy to do version. We're gonna have a long value. Let's actually register. Actually, no. We are going to go for string s and input. And this is only because the cycles isn't a one-to-one map between the inputs and this. So it's our parts split on spaces. Okay. So this is how easy. This is pretty easy. Doing a switch on parts 0. Case that it is no op. We simply just increment cycle, and that's it. The other case here being add X, cycle increments by 2. Is this going to want me to do? Okay, it's going to do that. Cycle increments by 2. And what's going to happen here is that after it increments by 2, we have to do register plus equals integer % of parts 1. There's no on that. Okay, and then so what does it want? It wants on the signal strength during the 20th, 60th, 100th, okay. So the big issue is that we could get to a point where cycle would go over like this. So I take that back. We are going to go back to this. Equals 0. While index is less than inputs dot size. And this is going to be get index because we're going to control it. That way cycle will always increment by 1 because it's easier if we go cycle by cycle on here. Okay. So in this case, nothing actually happens here. In this case, This just increments index. And we are going to need int delay equals 0. If delay equals 0, delay plus plus. Actually, we just do delay equals 1. Otherwise, if it's not 0, we can increment the register, and then we can set delay back to 0 and increment the index. It's just a hack here to make this work. Okay, so now that we have done this, so now what we can do is after we do a cycle, we can do now if sorry, if cycle equals 20. So that's the first cycle. I get 20 or was it 20, 60, 100, 140, and 180. And what we're gonna do is go ahead and do long part 1 0 part 1 plus equals register, and then here lap of part 1. Let's see, will this give me 104? Does not seem right. I must have missed something here. The interesting signal strengths can be determined as following. During the 20th cycle, register X is a value of 20, so the signal strength is... Oh. You multiply it. Ah. That seems more realistic. Okay, let's see if this is right. No. Give me the example inputs. What do I get here? So I want to begin 13, 1, 4, not even close. It's not, I'm saying not even close, but what are we getting? Okay, so this is going to be 20. So this is cycle 20. We have 21, which is right. Alright. So 60th cycle. We should have 19. That is correct. Oh, because I stopped early. I'm missing one. I am right, but I'm missing 220. And I bet you that means I'm going to get 13. Oh, no. Still wrong, though. $140, $180. Okay, so 2120. I already figured that. 6019, 118, 140, 21, 180. Oh, 180. No, 116. 220, 220, 19, it's 220, 18. This is during, not after. I put this here, does that fix it? No. Something's not right. In the 220 cycle, X is a value of 18, so the signal strength. Huh. So that is the issue. Is on cycle 220. It should be 18 instead of 19. And this one is an add 1, so that is the issue. Is it because this gets added after the cycle? After 2 cycles, the X register. Gotcha. So okay. I see. So it's this is the wrong spot. Is it just in the wrong spot? Like, is this supposed to be up here? Yes. Okay, I just had in the wrong spot. Okay. Back to my input. That it's kind of right. It's good enough. It seems like the X register controls the horizontal position of a sprite, specifically the sprite in the third is 3 pixels wide. The X register sets the horizontal position of the middle of that sprite. In this system, there is no such thing as a vertical position. If the sprite's horizontal position puts its pixel where the CRT is currently drawing, then those pixels will be drawn. You count pixels of the CRT 40 wide and 6 high. The CRT screen shows the top row of pixels left to right. Draws a single pixel during each cycle, representing each pixel of the screen as here. CPU instructions in the CRT, you should be able to determine whether the sprite is visible in the instant of the, if the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn. Okay. Sprite position. So it's got 0 and 1. Okay. I see. So it starts at cycle 0. So what we have to do is if math dot absolute of register minus cycle is less than or equal to 1. I want a string. Let's just do a string builder. This is going to be the output. So if this is the case, output append this. Otherwise, no else if, just else. And then for so we're gonna be outdoing. Okay, so it says it's 40 wide, so 4 int I equals 0. I is less than. I call this outputs length divided by 40. Actually, I can just do this. I can do string I can call this output builder, is probably better. That way I can call this output. Okay, I'll put that by 40. So then we can just do is system.out.println of output substring from I times 40 to I plus 1 times 40. And in theory, maybe. Oh, I'm missing that. Please? It worked for a line. They work for one row. What's the output? Is that really the output? Why does the output just die after the first line? Something's not right. Why does it just die? Register cycle. Ah, but this can be condensed down to that. Give me this example inputs. Does this also still do it? Yeah, this one also does it. For no apparent reason. But it is correct in the first line though. So what's up with the second? Oh wait. Oh, I know why. It's because this needs to be cycle 40. There we go. It's because it's just the horizontal, there's no vertical. It's, yeah, okay, yeah. I just missed that bit. Oh my goodness, it's so hard to read, but I have an output. B U C A C B U Z. Oh, please don't be wrong. Okay, we're good. We're good. Hey. How'd I do today? Not too shabby. Wow, that I thought I would get that quicker on the second part. But hey. Alright, hang on, let me remove this so I don't get that being outputted. I just get this. And then it's always so hard to read. Can I change it to be, or what's, there's like a full block character. Yeah. If I do that, look how much easier that is to read. I'll put a boolean up here. I'm gonna call this high contrast. Goes there. It's either that or that. Sorry, no, it's either that or that. or a space or a dot. So that can give me high contrast, but I'll leave this as false because this is what the real problem's asking for as the output. So, but I don't think, I don't think there's really much to clean up on this, realistically. I mean, this isn't great code, but it's not great code. Yeah. Okay. So, today's problem is drawing stuff to an output to like a video screen. Basically, the way today is working is that we are given this input, which is a bunch of instructions to do. There are only two instructions. One is a no-op, which does nothing, as you probably guess, or there's an add x, which adds a value to a register. The no-op only takes one CPU cycle to run, the add-x takes 2 CPU cycles to run, and after the end of the second CPU cycle, the register is then updated. So to do this, we initialize a bunch of variables. We'll sort of cover how these all are. And then I go into a while loop. This while loop is just here to help it so that way this while loop is running at a 1 cycle rate, if that makes sense. So every time this while loop runs, it's carrying out 1 cycle. And the ending condition is just to make sure that we only run this while we are not at the end of our inputs. First thing we do is we do the during cycle operation. So during cycle 0, this only works for part 2. There's no during cycle operation for part 1. For part 2, though, we are outputting to a buffer kind of deal. Whether or not the register is at the same location or is one away from the same register value. So that's what I'm pushing here. The %40 is because lines are only 40 characters long, and it just kind of cycles through. It just loops around. It doesn't have like a vertical count. It's just going around in 40s. That's what we're doing here. And then if it's less than 1 or less than or equal to 1, so it's one number away or less, we output the £sign or the period. I have a little high contrast thing here for making this a little more visible, but that's beyond the point. Then we go ahead and increment our cycle variable because now cycle is completed. And then we then output our value for part 1 depending upon that cycle as it's shown here. Then we actually parse our inputs because if it's a no-op, we just continue on as normal. But if we have an add x, the add x is special because it does things in 2 CPU cycles. So what we get around that is we have this little delay variable. If it's 0, that means we have not delayed yet, which we then just increment our delay to 1. That'll then have this continue on and go back and go through another cycle before actually doing the second step, which is then take the value in the second bit of the instruction here and add it onto our register value. We then reset delay back to 0. That then resets this logic. And then we increment our index again to go to the next instruction to read. And that's it. This part is just simple. We just simply output what's in our little buffer here. This time breaking it up into chunks of 40. That way, when we run it, this is the non-high contrast view. But the way that chunks it up into 40 characters, so we get the actual lines that show up. And it's a little hard to read, but there are capitalized characters. And I can change this to a little high contrast view. And we can kind of see them a little bit more clearly. That's it. There we go. That is day 10 all done. Much better than day 8, 9. Wasn't too bad. But anyways, thanks for being here. I'll see you all tomorrow for day 11. Peace out.